example of the close collaboration that we had on Intel's Pike Creek project, where Synopsys, Intel, and TSMC all collaborated to deliver this world's first UCI interoperability test chip. So I see collaboration as a sort of imperative adjustment that the industry has to do.
Are you ready for new and unfamiliar challenges around die-to-die connectivity, chiplet integration, and system reliability? Synopsys, backed by its broad experience, close ecosystem collaborations, and comprehensive IP and EDA solution, offers help for fast chiplet-based multi-die system development. Visit synopsys.com/multi-die. Hello, this is Ron Wilson, and I'd like to welcome you to the Ojo-Yoshida Report's video podcast series, Dig Deeper on Chiplets. Today, we're speaking with Shekhar Kapoor from Synopsys. And Shekhar, I think it would be good if you just introduced yourself.
Yeah, thank you, Ron. I'm Shekhar Kapoor. I am Senior Director of Product Line Management at Synopsys, and I lead the multi-die systems initiative at Synopsys, which is, of course, an area of deep interest in the industry. And so glad to be here, Ron.
With all the excitement we're seeing about the chiplets around the industry now, what kind of adjustments does the EDA industry have to make to support this?
So, Ron, the key question, the way I look at it is, what is EDA industry's role in this transformation that is happening to multi-die systems? If you look at it, EDA advances have fueled many waves in the last many decades throughout semiconductor industry's history. So multi-die system is actually also being enabled by EDA and IP, if I may. The question that we are really focused on is how do we make sure that our customers can continue to scale as they're trying to achieve with multi-die system and be successful during the transition from the system on chip to the system of chips, if I may, chiplet-based design. What stays the same with the multi-die compared to SoC design, but a lot of things are evolving and changing as well. We're now potentially seeing this integration of functionality, which could be tens to even hundreds of individual dies and many other components. And additionally, there are configurations and many variants which are available to connect all these chiplets together in 2.5D or 3D stacked, which really means there's a lot of architecture options, and that obviously brings a level of complexity. And here's why we see the collaborations across the multi-die ecosystems from EDA, foundry partners, and more are becoming very important. So aligning the broader industry along a common vector and pooling all this knowledge across many facets of design, and that is an area which is truly exciting and then becoming a must. But just an example is, of course, how we have partnered and across the industry and a close collaboration in Intel's Pike Creek project, where Synopsys, Intel, and TSMC, we all collaborated to deliver this world's first UCIe interoperability test chip.
Okay, you use the word collaboration a lot, and I think that's pretty much the way every new generation of EDA tools has emerged, from collaboration with foundries to collaboration with lead customers. Is there a point where you can say, okay, we're now ready for general customers to use this tool chain?
That's an interesting question, Ron. What is the definition of readiness? We are embarking on this journey of multi-die system design. The term that we call this new era, if I may, is SysMore. And I'm sure many are familiar with it now, which is really addressing the systemic complexity. And, our customers are trying to achieve this scaling for their application needs. But to achieve that effective scaling means that the multi-die system solution, which are as an option, really encompasses a vast design scope. So every application and every architecture choice that you make, you have to be ready in that context. So I would again contrast it with the monolithic world, where the big concern has been, you get, is that really the design level? You're only dealing with one die, but with multi-die now you have the entire system in mind. all the way from concept to manufacturing. So if you look at this whole concept of system technology optimization is gaining traction. The focus is, to not just think one component, but think holistically and in a more complete sense. Starting all the way from your software stack right down to all these myriad possible silicon technologies that you could deploy to meet the system specifications and bring up the system. So basically, the way we describe it, the days when you could simulate a design and toss it over the wall for verification, and then toss it over the wall to your place and route for implementation, those days are over. Foremost, being ready to me really means delivering the methodologies and solutions from architecture design to manufacturing all in one place to really accelerate this system development. But also, as we just talked about, it's a much larger task involving many disparate skills and solutions. Multi-die system design would require planning, coordinating across the ecosystem companies. That means, again, being in sync and aligned, looking at the standards together for interoperability and then convergence and efficiency. So participating in and helping create a vibrant ecosystem where you co-develop these crucial paths to address the common challenges. I think that also is another element of readiness. So having the solutions, the methodologies, the reference flows, that's one thing. And then also making sure that you build stronger partnerships and through which you develop the common standards and address these common problems.
Mm-hmm. It sounds like co-optimization is kind of a key indicator there, that maybe we're ready when you can pull together enough of the variables that have to be optimized in enough of a standard format that optimization tools can actually work with them. One of the things that I think people have talked about, and I think this came up in a panel that you hosted recently, is if we can get this working, can we have an open market for chiplets? Kind of like we thought once we would have an open market for silicon IP.
Yeah, so on the concept of chiplet marketplace is indeed an area of discussion, and there's some activity in the industry as well. There is no doubt considerable interest surrounding the area. It remains a topic of varying perspectives on the promise that it has and also the feasibility aspect. So while a general purpose DigiKey style chiplet marketplace is not probable in the broader sense, I think, yet there is potential for select standard chiplets. For example, HBMs, if we can call them, chiplets, or even the interface IP chiplets. So there is a potential to have a targeted marketplace around more common, more standard chiplets. For broader use, though, I think there are many challenges. Standardization is, of course, on the top of the stack. Is required to ensure compatibility and interoperability. Tooling which enables this integration is compliant with all these standards is obviously essential as well. And one area which is pretty critical when you talk about any broader use is the quality assurance. There's concepts of known good dies and so on. But the key challenge really focuses around, it really boils down to the fact that there are just too many requirements for customizations that are often there. Companies designing all these complex multi-die systems have very typically unique requirements, and you just can't take the chiplet off the shelf and plug it into the multi-die system and then make it work for your application. Case in point is you can see the automotive industry, where the requirements are very strict and specific. There are compliance, safety, reliability standards that have to be met. And so it's an open question that, an off-the-shelf chiplet could offer that or not. When we talk about not just for multi-die, even for SoC world today, the 2D world today, security is already a key concern, where you need to kind of authenticate each chiplet to make sure that, we're not open to attacks or vulnerabilities. In a scenario where you have the chiplets which potentially could be coming from different sources, that's a heightened concern that the industry has to deal with. And last but not the least, I think there are going to be intellectual property and liability frameworks that will also need to be developed before you can have a broad scale proliferation of a chiplet marketplace kind of. So there are I think in summary, there is possibilities in some limited ways, but having a general purpose marketplace is still further away.
It sounds like the typical design flow that you're describing perhaps starts out with some common off-the-shelf chiplets, then requires some ASIC design to create specific chiplets, and then has an additional stage for integrating the chiplets, creating the interposer or the substrate, and finally, a kind of system verification step that doesn't really exist in chip design. Is that kind of the right idea?
Yeah, so I think indeed, what you're seeing is a multi-die. There are more steps involved, and then you rightly said that there are more verification steps. So the most of these differences are really coming from the scale that you're dealing with and makeup of the system. The tooling is more, I wouldn't call it revolutionary, but it's more evolutionary. And because the scale is the main thing over here, which is the scope is much larger, because potentially you're dealing with very complex heterogeneous systems. And what we within Synopsys actually call, and it's like, I think it resonates very well. What we're really witnessing is a kind of a chip up disruption, because you're not able to grow in the X dimension. Now you're growing in the Z dimension. And which, when you go in that dimension, even if you're just placing side by side, or you're stacking the different dies together, they're obviously going to be more verification, reliability, and analysis, which comes into the picture. So you have a very expanded scope right up front, from architectural design to meeting functional and physical spec, thermals, and similar other KPIs. Chip package co-design and optimization comes into the picture, and the full system testability and lifecycle reliability comes into the picture. So of course it brings a lot of enhanced challenges, which you need to address in a very unified way. We've been used to having methodologies in place which have automated the whole 2D design or SoC chip level design. Similar approaches now will have to be made available in the multi-die system world, where you can go through all these in a much more unified and connected way and achieve the productivity that you're looking for, similar to what we used to for SoC world.
This is kind of asking you to look into the distant future, perhaps, but do you think that unified way can eventually evolve to the point that the design team could just do the system design and the necessary chiplet designs and the interconnect architecture and the substrate and the packaging can all be derived from that more or less automatically? Or is this always going to be a question of doing a large number of individual chip designs and then an integration phase?
It's a very good question, Ron. So absolutely, I think it's definitely the direction that the multi-die design is moving towards, really to enable these, I interpret it as more automation. We're going from the traditional, crawl, walk, and jog and run stages. The first stage of designs was exactly, I think, what you were alluding to. You have these systems planned in a 2.5D or 3D manner, but they were all implemented as separate dies. And then you're kind of bringing it together, assembling them together. You would just have so synchronous communication in this case that, for simplicity, each die from a timing point of view closed, implemented and closed separately, and then the system is brought together, assembled together. But for PPA reasons, it becomes inevitable, if you want to achieve more optimality, that you start taking advantage of the promise that multi-die system has. You cannot look at each piece separately. So it is moving in that direction. We are in the past the crawl stage, I would say. We are in the next phase where you have increased die-to-die optimization and also synchronous die-to-die communication, which is coming into the play. And there is clearly strong investment in the true 3D world, where you have this whole multi-die system designed and full stack optimized as a single chip. And that's where you would have, 3D place and route and 3D timing. And so that's the vision, it's of the unified flow, which I mentioned, which allows you to have this, to achieve this goal of not just look at individual pieces and just see that can we achieve the same what we have for this for the SoC design flow. So there is, to answer the question clearly, direction which the industry is moving to maximize what the promises of PPA and as well as cost.
Mm-hmm. One kind of detail in that scenario that I think you mentioned earlier, as I understand it, completing and signing off the multi-die assembly requires multiphysics analysis, especially thermal and mechanical. And in my experience, just the word multiphysics terrifies most SoC design teams. Is that something that we can hide in the way that we hid electrical stuff inside cell design? Or is it something that SiP design teams are just going to have to swallow and step up to?
Again, good question, Ron. Yeah, this is indeed one of the more known and discussed challenge in the industry. Multi-die, as you said exactly, that it's a heterogeneous integrated problem again. And one way to describe this is multi-technology, multi-tier, and multi-scale. Of course, you have many stacked dies which are involved. You have interposers, substrates, and in some cases, if you're integrating photonics, and you have different materials which are all coming together. So it inevitably brings all these different thermal, mechanical, and electrical characteristics, which we all call multiphysics issues. These are inevitable, the way to look at this. But of course, as you said, most chip designers are unfamiliar with it. In the SoC world, you don't commonly deal with that. These analyses are done, but typically by the experts or the sign-off engineers, if I may. So that's where, again, how do you address this problem? You cannot completely eliminate it, but can you make it more automated? Can you bring the efficiencies so that non-experts can also become comfortable running these analyses as part of their design flows? So once again, I'll reiterate that this whole idea of having a unified solution, unified platform, which would enable you to do that, to have that automation and the efficiency. We have, for example, worked closely with our partner ANSYS, as well as other partners, where what we have tried to achieve is you hide all these complexities of setting up and running these multiphysics analysis tools, so that even the non-experts can comfortably be able to perform the checks that they need. And we're also continuing to invest in our in-design solutions within the platform for thermals and silicon integrity compliance analysis, for example, to make it considerably easier for designers to perform these checks and then hand over to experts for more detailed analysis and sign-off. So short answer, it is possible, and I think that's what the whole purpose of having unified solutions and in design and native capabilities, which allow you to do that, while still, for detailed analysis, you can have the experts perform it.
Mm-hmm. In the short term, before we reach that goal, do you think we're going to see the emergence of a new subcategory of design engineers who are basically SiP sign-off experts?
Those experts are already there, but I guess they come late in the picture. Typically the way design progresses is that, the detailed analysis for sign-off purposes are performed later in the flow. Even in SoC world, you do have need to do all this analysis earlier and sooner. And what we are seeing is that multi-die is accelerating that whole need. You really need to have these expertise or these analysis actually done much earlier. So while there always been these expertise, and that will continue to be there with a greater need for multi-die, the big question is, how can you make it easier for everyone else to get the design ready to perform all these trade-offs that you need to do as they are architecting these designs or they're implementing these designs, so that there are not too many surprises for when it goes to the experts later on. And there's more convergent path in that sense. So yes, I think everyone will have to become thermally aware in their flows, EM aware, signal integrity, power integrity aware, as as they're building the designs. So some level of expertise will have to be adapted to. But the whole idea is how can you make it more convergent? How can you go through these flows much more productively? And that's where you have to provide, the EDA has to provide the solutions to make sure that these capabilities are available in a more easy to use manner.
It sounds like you're describing a tool evolution kind of similar to what's happened with the Fusion compiler, with sign-off tools moving into the synthesis stage.
Exactly. I think you touched on the button. Absolutely right, Ron. We've seen this journey, right? To your point, it used to be even synthesis and physical implementation and all used to be a separate components. They were handled by separate engineers. And then, of course, from an optimization purposes, we've seen the need to fuse these parts together. And if you think about it, I've been reiterating and talking a lot about this need for unified solutions. That's an evolution of that. We're going from 2D to 3D, and one of our customers put it very well, that there are no new 3D engineers being born. It's the same 2D engineers who have to do the 3D work. So if you see from that point of view, you need to have the same path available to them. If you're used to a certain 2D design flows, from that you should be able to easily move on to the 3D and extend in that fusion way from 2D to 3D, and be able to go seamlessly back and forth. So there is if you make a change from an ECO point of view, if you make a change in a die, that has to be easily seen or reflected at the whole 3D die level, right? 3D picture level. And that I think is only possible when you extend this fusion concept that we believe is not a luxury, is more of a necessity for the multi-die design world.
So in the meantime, it sounds like you see 2D designers having nightmares about at what temperature do copper pillars start to soften.
But that's where we come in there. That's where we need to make life easier, right? And provide all these capabilities. You're right. I mean, the architecture design also has been one of those things, seem like a distant world. But before you can commit these to implementation, there's a lot of upfront work that you have to do. And many of these KPIs that have started to appear very early in the flow, the architecture design level. Even the functionality, the functional architecture cannot be separated from the physical architecture. That's also another thing. We call it the marrying of the form and the function. So that's also becoming inevitable. And so it all boils down to providing these capabilities in a much more usable way, in a unified way where everyone can take advantage. And it doesn't seem like a big load. Suddenly you have to become a 3D engineer or a thermal expert, but yet you've got to be able to perform all these much more elegantly and efficiently.
Does that suggest that one of the things we're really going to want is a front-end visualization tool that helps to pull all these different things together for the system architect?
Again, a good question. I think this is exactly what we tried to achieve with, which was extension of, again, going from the fusion from, as in the context of Fusion compiler to 3D IC compiler. The real purpose over here is, and customers really want to visualize in one place, build in one place, and then you want to optimize also in the same place. So you're right. When you're doing this architecture planning, you have to be able to see, you have to be able to play around with all those disaggregated pieces or the integrated pieces that you need to have to achieve the optimization for your system. So that is something, visualization becomes a critical thing. Interactivity becomes a very important thing. And so all those are the intended benefits that we want to provide with the TDIC compiler platform in that case. And then I think this is industry has been demanding it, and multi-die system requires it. So in that sense, it's not something that which is out of the league in that sense. It is required.
Oh, I think you've given us a really fascinating view of the evolution. Now for the hard part, to put some time scale on it. What do you see happening next year and beyond that? Are we still in a very formative stage? Are we going to see some major advances in 2024? Are we going to see some major advances in 2036?
So that's the Ron, that this train is moving fast. That's how I look at it. It's you sort of, you're asking me to look at the crystal ball, but I think crystal ball is busy right now. That I can tell you that. Right? And this inflection point, actually, there's not a sudden uptick, a hockey stick or something like that, but inflection point has been the last year or so, I would say. With all these compute demands, end of the day, these are the ever-increasing compute demands which are driving it. So 22, we saw a lot of focus, all the standards coming online with UCIe and other industry standards for design construction purposes and all that, which have really give a good impetus to where we are going. So now we're seeing more and more design starts. There were a lot of people who were sitting on the edge, a lot of customers, but now that actually with the opportunities that are being provided by the enablement, by the manufacturing, is opening up the doors, opening up the gates, and HPC and data center and server market, of course, clear. The AI market, pretty clear. They don't have an option but to aggressively march forward with building these multi-die systems. The entire system is basically coming into a single package. But others, such as automotive, there's a lot of excitement. So that's where we're seeing the design starts coming as well. So in terms of, I think the activity across the different application or verticals is becoming clearer, is increasing. And then alongside that, the whole ecosystem readiness, it goes hand in hand. If the ecosystem is not ready, then of course, experts can do anything. There are experts in many companies, but for everybody else, you need to have the readiness. And that's, I think, what has been, we're seeing the maturing ecosystem, which is enabling this wider adoption. And then, of course, we're doing our part in terms of, as I mentioned, that bringing in new automations. And that is now extending from full stack, essentially silicon level automation that we're used to bring to the entire system. And I touched upon the idea of 3D heterogeneous integration being enabled by the true 3D implementation and timing analysis and sign-off. So those are in there. And STCO, we've been used to DTCO, the design technology co-optimization, which has delivered then the entitlement for each successive process technology. STCO is the one which really allows you to go all the way from device level to the architecture level and optimize the entire system. So that paradigm is very clearly a lot of attention that Synopsys has, a lot of investment we are doing in that area and across the industry as well. So that's going to become a reality to deliver these systems. And last thing, it all starts with these AI demands, which are leading to compute demands. And for our own purposes, AI is clearly in the mix. Uh, Pervasive deployment of AI we see as a potential to significantly transform the system design. We again have seen in the 2D world where you have the design space optimization and the productivity benefits you can achieve through that. In 3D space, the opportunity is even bigger. Think of the whole three-dimensional design space optimization that is out there to be addressed. So we see a lot of AI capabilities coming online to boost the productivity. So many things happening, Ron. There's a lot of excitement in the industry around multi-die because of the benefits that it can deliver, and so we seeing a lot of technologies coming in there, ecosystem coming together, and it's a very bright future.
It sounds like if AI is really necessary to cope with the enormous design spaces that you've described, Synopsys's prior experience with DSO could turn out to be very handy in moving all this forward.
So yeah, so we have there is a huge opportunity in front of us to solve complex problems, complex optimizations problem, and Synopsys' solution is called DSO.ai, Design Space Optimization.ai, which is essentially a reinforcement learning based technology. Wherever you have a lot of expertise required and a lot of simulation and analysis required to address complex optimization problems, that's where technology like DSO.ai comes to the help, and it can really automate, and you don't need the expertise to know all the details about your design. You can leverage this AI-enabled technology to achieve the most optimal results faster, which the human effort would require significantly more time, and then you may still not be able to get to the optimality that your application needs. So end of the day is productivity, and we have seen that even with the best experts working on a design, you can still achieve a few numbers better, even 5 to 10% better QR results, PPA results, and sooner by using technology such as DSO.ai.
So if I understand correctly, the machine learning tool learns from prior experience where to look in the design space and directs the design team efforts there, rather than actually generating a solution itself. Is that right?
So it learns from reinforcement learning concept is, it fire off a simulation and then it will learn from it, from the results that, is moving in the right direction, and then target the subsequent runs based on its learning in the most in the right direction, per se. And in doing that, of course, be able to achieve the better results. We have our customers have tasted success, I would say. We have shown the value that having ML-based technologies in solving the complicated optimization problems. And 3D world or multi-die world is no different. It's actually much more exaggerated, if I may, exacerbated the problem. So we are applying same techniques and extending them. There are problems to be solved all the way from architectural planning to your signal integrity optimizations, and all the way through, thermally aware design, how AI can benefit over there. So scope is incredible, and I think there's a huge opportunity out there that we learned a lot from the DSO benefits, and customers' own experiences have made us learn.
Well, this has been absolutely fascinating, but I'm afraid we're out of time long before we're out of interesting topics. Thank you very much for your time on this and the very valuable information.
Thank you again, Ron. Thanks. Glad to be here, and look forward to another opportunity.
Are you ready for new and unfamiliar challenges around die-to-die connectivity, chiplet integration, and system reliability? Synopsys, backed by its broad experience, close ecosystem collaborations, and comprehensive IP and EDA solution, offers help for fast, chiplet-based multi-die system development. Visit synopsys.com/multi-die.